Welcome everyone. Today, we begin an exciting journey into coordinate geometry, one of the most practical and fascinating topics in mathematics. Have you ever wondered how Google Maps identifies your exact location? Or how engineers design buildings with precision? The answer lies in coordinate geometry. In this lesson, we will learn how two simple numbers can identify any point on a plane, measure distances, calculate areas, and divide line segments accurately. Let's begin. The birth of a new language. Over 350 years ago, the French mathematician René Descartes transformed mathematics forever. Before Descartes, algebra and geometry were studied separately. His brilliant idea was simple. Every point on a plane could be represented using two numbers. This invention created the Cartesian coordinate system, connecting algebra with geometry and laying the foundation for modern mathematics, engineering, computer graphics, and navigation. Understanding the Cartesian plane. The Cartesian plane consists of two perpendicular lines. The horizontal line is called the x-axis. The vertical line is called the y-axis. Their intersection is known as the origin, represented by 0, 0. These axes divide the plane into four quadrants. Each quadrant has a unique combination of positive and negative values, allowing every point to have one unique position. Ordered pairs. Every point on the coordinate plane has an address called an ordered pair, written as x, y. The first number is the x-coordinate, also called the abscissa. It tells us how far to move horizontally. The second number is the y-coordinate, also called the ordinate. It tells us how far to move vertically. Remember, the order is very important. The point 3, 5 is completely different from 5, 3. From location to measurement. Now that we know how to locate points, the next step is measuring distances between them. Coordinate geometry provides powerful mathematical tools that help us calculate distances, areas, and positions with complete accuracy. Let's first understand the distance formula. Distance formula. The distance formula is based on the famous Pythagorean theorem. Suppose we have 2 points, x1, y1 and x2, y2. First, find the difference in the x values. Then find the difference in the y values. Square both differences. Add them together. Finally, take the square root. The formula is distance equals square root of open bracket x2 minus x1 whole square plus y2 minus y1 whole square close bracket. This formula is widely used in surveying, GPS systems, engineering, physics, and computer graphics. Geometric proof. Why does the distance formula work? If we draw horizontal and vertical lines between 2 points, they form a right triangle. The horizontal distance forms one side. The vertical distance forms the other side. The actual distance between the points becomes the hypotenuse. Using the Pythagorean theorem, we obtain the distance formula. So, the formula is not just algebra, it is actually a geometric truth. Beyond lines to shapes. So far, we have measured distances. Now we move to another important concept, measuring the area enclosed by points. Coordinate geometry allows us to calculate the area of shapes directly from their coordinates. Area of triangle. Suppose the 3 vertices of a triangle are given. Instead of measuring lengths manually, we can directly use the area formula. The formula is 1/2 multiplied by the absolute value of x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2. This formula is extremely useful in land surveying, architecture, engineering, and computer graphics. Section formula. Sometimes we need to find a point that divides a line segment in a given ratio. For this, we use the section formula. When the point lies between the two endpoints, it is called internal division. When it lies outside the line segment, it is called external division. A special case occurs when the ratio is 1:1. In that case, the point obtained is called the midpoint. Distance formula example. Let's solve an example. Find the distance between the points 2, 3 and 4, 1. First, subtract the x-coordinates. 4 minus 2 equals 2. Next, subtract the y-coordinates. 1 minus 3 equals minus 2. Now square both values. 2 squared is 4. Minus 2 squared is also 4. Add them together. 4 plus 4 equals 8. Finally, take the square root, which equals to 2 square root 2. Section formula example. Now let's apply the section formula. A relay tower is to be placed between two locations. Point P is at the origin. Point Q has coordinates 36, 15. The point divides the line in the ratio 1:2. Applying the section formula, the x-coordinate becomes 36 divided by 3, which is 12. The y-coordinate becomes 15 divided by 3, which is 5. Therefore, the required point is 12,5. This example shows how coordinate geometry helps solve practical engineering and communication problems. Let's summarize today's lesson. We learned about the Cartesian plane. We understood ordered pairs. We studied the distance formula and its geometric proof. We explored the area of a triangle. Finally, we learned the section formula and solved practical examples. Coordinate geometry is one of the most useful branches of mathematics because it connects numbers with real-world locations and measurements. Thank you for watching, and happy learning.